Now one more example. Second, one more sorting technique we are doing using brute force technique is called as bubble sort. It's a very simple sorting technique in which we are just comparing the adjacent elements of the list, and if these elements are in unordered, we just exchange them. Once we are doing this process repeatedly here, when we are doing this process repeatedly, we are end up bubbling up the largest element to the last position in the list. That means when we are repeating the same exchange, in one pass we found that the highest or the largest element is pushed to the or bubbling up to the last element in the list. In the next pass, the second pass, we bubble up the second largest element to the last but one position. We will do the same process up to n-1 time. In the n-1 time, we will already sort all the elements in the array. If you see in the ith pass, what is the state of the elements of the array? In the ith pass, if you see, these number of elements are already in the sorted order. Here in each pass, the largest element is pushed to the end, and in the ith pass, these number of elements are already in the sorted order. Now I have to sort this number. Here it is comparing each adjacent element, and if that element is larger, it is pushed to the right side. Okay, when all the elements push the largest element to the right side, here the largest element is stored in the end. So that is indicated by this diagram. Now how actually this algorithm works? Now see this one. This is called as bubble sort algorithm, which will take array as the input of size n. Once this bubble sort will be done, the output will be sorted array in non-decreasing order. We have again two variables I and j. I is actually the number of pass here. Total number of pass is indicated by I, and j actually indicates the adjacent elements of the array. We have to conduct I totally n-1 number of time. Totally we need n-1 pass. And j is actually starting from the first element to the n-2 minus I. That means the array which is not in the sorted array, sorted element. We have to start from 0 to the last element which is not sorted. Okay, now we have comparing here the second element with the first element. In the first pass, we are comparing the second element with the first element. If second element is smaller, we have to just swap it. Again, we have to in the next here, when the j increments, we are comparing the third element with the second element. If the third element is smaller, we have to swap it. We have to continue this process up to n-2 minus I time, up to end of the unsorted list. Once you reach the end of the unsorted list, the largest element of that unsorted list will be pushed to the last. So this is actually the algorithm shows. If you take this example, you comparing first with your second element. Okay, you found that 89 is larger, and this is called as j. This is called as j plus 1. This is j, j plus 1, you found that j plus 1 is smaller than j, you just do the swapping. Here you are doing the swapping. Next, j increments, and this becomes j, and this becomes j plus 1. Now, j plus 1 is again smaller. If condition is true, then you just do the swapping here. Okay, here 68 is replaced with, exchange with 89. 89 comes here. Again, the j increments, and j becomes this one. J plus 1 is this one. You see this one, this 90 means j plus 1 is larger than 89. Here the if condition is failed. Here the if condition is failed here. So we are not doing any exchange in this situation. Since j plus 1 is larger, we are doing no exchange. So we are comparing this 90 with 29 again. If you see this one, 90 is actually larger than 29. This is j plus 1. J plus 1 is smaller. So you have to do the exchange here. 90 comes here and 29 comes here. So this is here 90. 90 is compared with 34 here. Again the swapping will be conducted because j plus 1 is smaller. So 34 is come here, 90 comes here. The last here also the 17 is smaller than 90. So 90 is pushed to the end. So if you see properly from here to here, the largest element in the array is bubble up to the last position of the array. So it is called as bubble sort. It's look like a bubble. When you apply some swapping diagram here, it's look like a bubble. So it is called as a bubble sort. In single pass, we found that the largest element of this unsorted array is pushed to the end of the array. In the second pass, I have to sort on these number of elements. So I am putting there, it's nothing but the n minus 1 minus I. I means I am just skipping this element. There is no need of sorting this again because this is already in the sorted order. So I am putting there in the algorithms n minus 2 minus I. That indicates now I have to sort from 0 to up to n minus 2 minus I. There is no need of sorting this one. The next pass, if you found here I is incremented, if these two elements are already in the sorted order, I have to do n minus 2 minus I. Swapping has to be done from here to here. If you continue the process from pass 1, pass 2 up to pass n minus 1, you found that all the elements are in the sorted order, just bubbling up the largest element to the unsorted list. Now the analysis of bubble sort. In the first step, we found that the array size or the number of elements in the array increases, our algorithm will take more time to execute. So the input size is nothing but the number of elements in the array, that is nothing but n. Just like selection sort, here also the basic operation is nothing but this comparison operation, that is a j plus 1 is lesser than a j. If this here, this is called as the basic operation of the algorithm because this will be executed more number of times. Okay, as the loop size increases, it will execute more. So this is called as the basic operation. Next, we have to find out is there any best case and worst case is available. We found that there is no any best case and worst case because iteration has to be done without any predetermination. So there is no any best case and worst case. Next, we have to apply some summation formula there and identifies what is the or how many times this basic operation runs. That is indicated by this summation formula here. This is for outer for loop. This is for the inner for loop. We found that I is equal to 0 to n minus 2, and j value here starting from 0 to n minus 2 minus I. And this is for basic operation. One is indicated for basic operation. When you simplify or substitute this formula, you found this n minus 2 minus I comes here, and this is the 0 here and minus 1 here. One you decremented here, one is decremented by here, 2 is decremented by 1. You found n minus 1 minus I. This is nothing but this formula you already solved in the previous classes. This formula is already solved in the previous classes. Its result is nothing but n minus 1 into n divided by 2. That is nothing but theta n square. Means bubble sort require or bubble sort order of growth is theta n square. Now we have to identify the number of times the swapping operation works. If you see here, it's very difficult to say how many times this swapping operation works. It depends on the elements given, the number of elements given. Depends on the input elements. So we can calculate the worst case for the swapping operation. How many times this swapping will be done is indicated by, in the worst case, it's nothing but S worst n is equal to C of n. Totally it will perform n minus 1 into n divided by 2 times swapping. This is the worst case when you give the elements in the decreasing order. When the elements are given in the decreasing order, it will take these number of swappings. Okay, and it is nothing but theta n square. The worst case and average case for the bubble sort is theta n square.